Good morning, good afternoon, and good evening, everybody. Welcome on in. How's everyone doing tonight? Mystery, I see you got here first. Nick, welcome in. Hope everybody's having a good day. It's been a fun week so far this week. It's still kind of a up in the air week with everything going on at work, just because we're we just went through some uh, workforce reduction. Now we're trying to go through the next piece, which is all the reorg work to actually realign the people left with work that's fun times, fun time. Hey, Shaudel, how's it going? Welcome in. Come on in. So once again, we're back. We're working on the Enraged Rabbit Carrot Feeder version 2 build today. We've been working on this, started this past Thursday and made a good amount of progress. I think we're going to make some good amount of progress again today. Things are going to come together fairly quickly. Next, go ahead and put the screen around. So kind of got things laid out. Of course, got our coffee, had the coffee those days. And what I've got laid out here is the gearbox and gear drive assembly that we had worked on at the very beginning. This is the first thing that we put together. We'll be using this again today. We've got our lane pieces, and I took them into their separate pieces after I put them all together and checked them all out and made sure that the fit and finish was good. I did go ahead and take the lane, the filament lane pieces, the other pieces I just left on there. I took these back off because the next thing that we're going to be doing is mounting our filament blocks onto this bar. And you'll see that we're going to need to have that top off so we can get each one of the drive gear uh, rub screw into this side of the block as we. So I've got my blocks lined up 0 through 7, um, which I find this interesting. So in computers and when you're doing the binary stuff, we always start off with 0, not 1. You'd think we'd start off with 1, so we go lanes 1 through 8, but we really go 0 through 7. And to see them do that, on the physical side here as well is kind but what we're going to do is we're going to go ahead and bring up our directions. Hey, Hybrid Robotics, welcome on in, my. Hey, Ozzy, good morning, good morning, good morning. So in our directions here, we just finished off assembling and checking all of the tolerances on our filament block. So we had our full assemblies put together. We tested that they've got a little bit of springiness to them because of the two magnets that are opposite polarities, right? Um, and so then we didn't need to check any of the clearances here, or we didn't need to use either one of them. Good there. Um, Next up is actually mounting our filament block array. Oh yeah, Friday Down Under, huh? Well, we are here enjoying our leap day for the leap year, February 29th. So doing good there. So we're going to get started. And what I did was I went ahead and I got all my drive gears out of their bags and got them just laid up here so they'll be easy to grab hold of. I also grabbed 8 of our M3 T-nuts, 2020 T-nuts, and I've got 8 of our M3 by 8 nut or bolts out, and that's what we'll be using to mount our lane. And so what we're going to do is orient our gearbox this way. We're going to start inserting all of our pieces from this side. Now to make it easier, I'm going to rotate our shaft so that my flat edge of the D shaft is facing up. So what we're going to need to do for each one of these is going to put it on is, of course, get some of our Loctite on the grub screw. A little bit of Loctite. And we're not going to lock this down. We're just going to get that started. We're going to put it in with the, I'll say the drive gear. So the drive gear portion goes in first. In fact, let me see if we can't bring this over here and kind of get an up close and personal as we're doing this. Yeah, so we're taking our drive gear and we're sliding that on with the larger end of the gear first. We're going to just screw or move this down a bit. We're going to take a M3 T-nut and we're going to put it in with the hole. Sorry, with the hole facing towards the gearbox. Okay, so just like that. And then we're going to take our lane, our filament block, and we're going to, using the nubs, use that to line it up and this hole here, and we're going to use a M3x8 screw to lock this down. Hey, projects in Dad's garage. I am doing the standard parts. I am building this as a standard plain vanilla ERCT V2. So I'm not going to tighten this all the way down. I just want to make sure that it's biting into the T-nut because we want this to be able to move. We're going to line the shaft up on the bearing like so. And then we're basically just going to push everything on over up against the end here. And you'll see that that will bring our gear in line. Okay, and we're not going to tighten anything down yet. We want it all to be kind of left loose for the time being. And we're going to do this for all 8 of our blocks. Apparently they do want me to start doing a little bit of a line. So we got the first one in here. See if I still can't get. Sorry, folks. I'm trying to figure out which one to undo to adjust my smaller. Twist it over. And thanks for the follows. Projects in Dad's Garage. And I am using the MMB. Folks, give me 1 second. I'm going to mute myself because I need to blow my nose real fast. Bear with me 1 second. Okay, thank you for that. So yes, projects in Dad's garage. I printed all of this stuff, or all of the parts to be the basic parts using the cottontail with the MMB. Um, so yeah, that's kind of the plan for this build. So we've got this lined up, and the parts, by the way, this is Polymaker ASA Pop Pink and Pop Blue, and it's these colors were chosen because this is going on the DFH Trident 350, which are using the same colors with a white frame. All right, cool, Hybrid Robotics. Hopefully no problems picking up your scripts, and see you back when you can. Rabbit, not familiar with that one. I have a standard easy board. I actually bought this and was planning on using this on a trad rack, and then I finally got my beta board for the trad rack. So I've got the beta Annex Engineering board for it, and we're going to reprint all the parts for the trad rack using the latest open source beta files. Because when I built mine during the closed beta. So I'm going to reprint the parts so it matches the color scheme of the Annex Engineering K3 and install that on the K3 using the Constellation board. But I've got a standard ERCT Easy board, and I've got a CAN bus version from Mellow as well. So let's see, filament base mounting. We've got our filament block in here. We've got our piece open. Push the Bondtech gear and the base to the gearbox. The drive shaft should not bind on the bearings. Snug the Bondtech gears in a central location. We will do fine adjustment later. But we need the gear to rotate smoothly for the array alignment step. Okay, so once again, we need to make sure it's pushed all the way over. We're going to get our gear sort of lined up. We will go ahead and snug down our set screw, because we will need this to be able to rotate. Got that snug down for now. And push the filament path onto the base. It should seat without much force and close the latch. Now we're going to take our filament bath part and line that up, put that on there. And latch it. Okay, that's one lane done. And repeat these 4 steps for all of the bases in the filament path. So now it's just a matter of doing this 7 more times. Make sure you don't forget to put your Loctite on your grub screw, or that will lead you to have a bad day. And I'm just going to go ahead and get these kind of moved down towards a lot closer down here, basically. It did tell me to push this all the way over, but not necessarily to screw this down. there's the final tighten there. Well, right now we're just getting our gears sort of quasi lined up and then making gears tighten down and lay together. But yeah, I've got the stuff. So I purchased. Well, no, let me back up. So the DFH 350 kit I got during the holiday when they had the sale, and as part of that deal, it came with a 6 cart Enraged Rabbit Carrot Feeder 1.1. And so what I did was went ahead and bought the both the Sea Lead Labs um, uh, upgrade kit as well as the Triangle Labs upgrade kit. Now, what I'm installing now is the one from uh, Triangle Labs, and so far it's been pretty good. Um, and then I'll have the Sealy Labs, and when I bought my MMB board, surprisingly enough, somehow, and I'm not arguing, I got 2 boards sent to me. So I actually have a second update kit and a second board that I can use to build another one of these. So I'm going to build another one of these to go on one of my other Vorons. I'll wind up with 2 of these, the Trad Rack. I've got a MMU 3 on order for the Mark IV. And then on our Saturday stream, we are building a black box tool changer. So this is definitely going to be the year for multi-material and tool changing in the Dragon Den. Got a roll of metallic blue ASA for the tap changer project. Nice. Yeah, I haven't looked at their say their metallic ASAs or ABSs yet. I do like the Sparta 3D. I've used on the actually on the um, Bubblegum Dragon, which went up to Free Heathen. That was a Voron V0, named by himself, and the um, K3 again behind me. I use Sparta 3D PC ABS for that build, and really, 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 really like it. Got just the right kind of metallic fleck in it. And I've also used their stuff um, on my Trident 300, aka Iron Dragon, and everybody named it Iron Dragon. I used their fluorescent or sparkle fluorescent red and sparkle old copper for that one. And I love that build. The one that's sporting my logo on the side panels. Hey, Two Wolf Designs, welcome on in. Royal Nomi, welcome in. Hope you're doing well, Nomi. You're doing things out of order. Hanging? Good. Good, good, good. Am I still going to see you at the end of the month? Well, I say at the end of the month. I'd say at the end of April. Hoping I do. Yep, it doesn't take much. I was thinking of wearing my zombie or my hedgehog make shirt, and I figured no, I should really actually wear that the day that we're finished with this build, because then we can say, hey, at least somebody with a hedgehog make shirt finishes a project. Unless that's violating like a trademark or something. Somebody will have to let me know. I know, I know. I gotta give you a hard time, Austin. It happens occasionally. Now, Zombie, you haven't actually done a an MMU, have you? You just got the Bamboo Labs AMSs. You haven't actually built an AMU unit of any type yet. Um, not. It shouldn't be that hard. The biggest thing is it depends on if you're changing the number of carts up. Like this is supposedly taking a 6 cart to a 2 cart, or excuse me, a 6 cart to an 8 cart V2. So it did have the extrusion, the drive gear, and the rods. and I may have to buy a couple of these pieces, like the long D shaft. I would need to source, but I've got plenty of 8 millimeter rod that I can get down if I needed to. So at that point, it would just be, um, you know, I think I pretty much have everything else that I would need to get one of these up and running between spare parts from. Yeah, there's no emission price for Murph. I don't think there's an emission price for any of the Rep Rap festivals, um, which is nice. Now there is a price if you want to have a booth, or if you want to have well, makers tables for Rocky Mountain. There was all been sold out, but it was a very minimal charge. Um, but Murph is literally first come first serve for makers table. You have a 9-part ERCT. Okay, so you got a 9-part ERCT for V1, 1.1. I don't see why you shouldn't be able to update to the V2. Um, Now I don't know if there is a difference in the part sizes because I have never built or printed out the parts for a V1. So I'm not sure if it was just a. Um, I'm not sure because I know on the V1 1.1 it was what 6, 9, or 12 cart, and this seems to be like 8 is the minimum cart on this size. I don't know why. Um, yeah. So I have them all in there. Now next up, tighten the filament blocks up against the gearbox and each other. Tighten from the gearbox out. Okay. And this is great because they show it without the top hats in there, and I don't know if I can get the top hat out without unlatching them. It knows. These out. You're gonna drink some herbal tea in my coffee cup? Okay. I see how it is, zombie. I see how it is. That's okay though. Okay. I drink tea every once in a while when I'm when I'm sick and feeling cruddy. Kind of my tell if I ever walk in and order tea or tell my wife I don't want coffee, I want tea. She knows I'm feeling like crap. So, oh, I was going to say drummer. Okay, you're going to go to dinner with the old man. All right, cool. Well, tell old man I said, hey, looking forward to seeing you guys at the end of the month. Yeah, that's why my plan is to go bone stock because with bone stock, I have the best chance of getting a working MMU. And then if I want to down the road, then I can go and start getting all like crazy and stuff. I'm just going to try and push this up against the cart and tighten that down. And then once again, with it tightened, you want to start turning the shaft to make sure that you're not binding the shaft. If you're binding the shaft, just undo it some. Then take the next cart, push it over, make sure it's nice and tight and snug. Tighten that one down. Okay. Third one, over. Fourth cart. Good. I am feeling some tightness, so doing good. Make sure that all of our lid pieces or our gears are in line. Now, Bondtech gear alignment, insert a small piece of PTFE, a few centimeters is enough, into the filament block. Insert a piece of filament through said block and check for fit and finish. So I happen to have a small piece of smaller piece. Oh, work. Got a small piece of PTFE tube. And insert this, whoops, in front, back, or whatever side this is. Then we're going to take and check our filament path with a little bit of filament. Hopefully, isn't too brittle. I think the issue I'm having with this filament is just that it's been out, it's old, and it's been sitting out, and it's kind of cantankerous. So we've got our filament pulled in there. And we're going to do the Bondtech gear alignment. So flat surface of the shaft is facing towards the M3 set screws, which is. Press down on the filament path and use the filament to align the center. We're going to use the filament to align the center of the drive gear. Okay. And I think we're going to do this for all of them. And it does remind us, don't forget to use thread locker on your printed parts. Or not your use thread locker on your gears and make sure not to get it on your printed parts. That's what I do it like aftershave. Just slather it all over your printed part. It's not gonna hurt. Um yeah, well, and I have done a MMU before. I did a MMU2 on the Prusa Mark III, and it works extremely well, but you've got to really get your filament pass really aligned. And then once you get your filament pass aligned, it's really making sure that um your your load lengths and everything are set properly. Now sensors really help that, but having those load lengths set properly makes the sensors work so much better, right? So that's the big thing there is it's all about tuning in your MMU. So you're going to have to spend some time regardless of which MMU you use in order to get things dialed in. Okay, what's going on here? Let me go ahead and make sure you got a good. And like I said, this is definitely not. So the end of a roll, and it's probably a little bit waterlogged. Like I'm surprised I'm not snapping it apart by now. The issue here is just aligning into the hole. I was pretty close on most of my alignments, so it's just a matter of doing that final tweak to get my gears to align up. Like I said, at this point, I'm just fighting my actual filament. This isn't, I don't think this is necessarily the hole. This is filament that I'm using. The other thing on to get good success out of your MMU, make sure you dry your filament um, and it's not getting nice and brittle. Because the one thing I had with my MMU2, I had we'll call it the long slender box buffer system that I built for it. And I would always have, especially white filament, would snap in that from being dry and brittle, snap in the buffer system. Um, Sometimes it would be an issue during the print. Sometimes it would be an issue between prints. So if you're printing kind of back to back to back, your filament's going to stay pretty good for the most part. But if you print and then you let it sit there for a couple of weeks and then go to print again, it's probably going to bust um, in your buffer system. So just be aware of that because that'll give you some problems when you're first starting up your prints. And again, tip forming will either make or break you as well, is why we've got the Filametrics tool cutter on the tool head. And oh, hey, Osita Craft, how are you doing? Welcome in, my friend. Yeah, the Dragon High Flow, you really need to have some good cooling on that tool head. But as long as you do, you're going to get some good prints out of a Dragon High Flow. There's a new hot end called the Next G. That is a heck of a hot end. Um, and it mounts just like a Dragon, and it has the ultra high flow variant adapter that you can add to turn it into an ultra high flow. And I was running that with the ultra high flow adapter with a zero point 0.6 nozzle and getting well over 45 millimeters cubed per second flow rate out of it. So definitely worthwhile to check out. And it mounts just like a Dragon. Okay, Project and Dad's Garage. Have a good night. Thanks for hanging out with me, or with us, actually. So, gear wrench, torque screwdriver is correct back and okay. On your day off. Awesome. Hey, Pez Liz, how's it going? Yeah, you missed it earlier. I made the comment that I thought about wearing Hedgehog Makes shirt today, and I realized it would be better to wait until we're done with the project and then wear it. That way, at least somebody wearing the Hedgehog Makes shirt has actually completed a project. And then your boy Zombie made a comment of like, okay, that's it. I'm going to start drinking herbal tea out of your coffee cup. I'm like, okay, touche. Point made. Okay, so we have all the filament blocks in. Now we're going to go through and replace all of our top hats. And these are not number coded, so they can go back in any order. Just need to get them in place and pop them in. Now I did print these out in the 2-piece, so you'll notice there is a tiny seam there. And there's M2 by 10 self tappers that are used to join these together. But it definitely makes it easier to print, and you don't have to print with a bunch of support material on those. Okay, so here we have it. Full setup for the time being. Probably turn it the other way around. Input in would be on this side. This would be the output in. This is where we'll be putting our LEDs in eventually. And take a break. You're on a seafood diet. I see food and I eat it. My wife, she should embrace her mistakes. She gives me a hug. Why don't scientists trust atoms? Make up everything. Reading a book on anti-gravity. Possible to have a joke about time travel, but you didn't like it. Nice little uh-oh. Uh-oh. So Zombie's not feeling well. Gotcha. I didn't realize that. Hope you feel better. And yeah, like I said, I always drink some type of herbal tea when I'm feeling sick. I get it. It will get tea occasionally. Okay, so now we're going to work on the end block. We've got 0 through 7 down here in our systems. And like I said, I've got the printed numbers to put in here. Um, yeah, they're kind of really, really small. So I'm not sure if I will be putting those in there with super. Hey, your wife was merely sharing. Okay, so our end block breaks out and does the exploded view of things that we're going to need to install this so you can get all your bits and bobs and parts out. So we'll need a ECAS coupler, both parts. So the black, gray, and the blue. We're going to need 5 M3 roll-in T-nuts. Sharing is caring, that is true. Hey, Stephen Poole, welcome in. Sorry if I missed you there. Oh, well, thank you, Siri. I love when she decides to engage out of the blue and scare the Jesus out of me. 5 of our M3 by 8 pocket head cap screws. M5, M5 locking nut, and earth this is because 5 regular nut. 30 button head cap screw. The end bypass foot and end bypass STL. So that would be our bypass and our foot we're going to be using. I think we got everything out here. So we're going to slide 4 M4 or 4 M3 T-nuts into the channel. Coming in on this side and back side. Looks like in both cases the holes are the screw holes are facing into the extrusion. Which Bean Boozled edition did you? Uh-oh. I keep hearing about you guys doing the Bean Boozled. And I'm like, yep, nope, I'm good. So we need to put our ECAS fitting together and get it on the bypass side here of our piece. I find it's a little bit easier to get the black and gray part in and make sure it's nice and flush. Then we'll get our blue part set up and push this in. Make sure your coffee is not on your bench and full. Because when these snap in, it has a tendency to kind of bounce everything around. So if you got a full coffee cup, it's not going to be full when you're done. And the bypass ECAS matches the rest of the ECAS fittings. Your bearing piece is going to be able to slide right in through the hole there. So we're going to line this up. Shaft goes through the open hole there. And we will work on getting our holes lined up. What I'm going to do is I'm going to do the kind of the first hole front and back and then move this around to get everything lined up. And then we will tighten things up. Need your magnetic. Yeah, after hearing those two and liver and onions and some of the others, what is it like boogers and stuff. I'm like, yeah, no, no, no. We're good. Then I'll just push these down a little bit and hopefully get the other two lined up. We're going to push it all the way down along the end. If it doesn't line up, just use a pair of tweezers or something to pull our M3s T-nuts into alignment. Those screws started. Okay. Now they're started, but they're loose. Let me see. It does say secure, so we will go ahead and secure. So I'm going to push this down, sure everything's tight, and then go ahead and secure my M3 by 8. Okay. Now we need to take the other M3 T-nut. Looks like the whole piece goes in first, and this goes on the underside. Flip this over, and the hole goes in first, so the hole is facing this side. Going to attach the foot, short side, long side, and they've got these little divots here, and you've got the little pen sides here, so that will help to line things up. Make sure that everything is got proper alignment. Another M3 by 8. And now our feet are all on there. We're good. In block, what about the M5 by or the M530 screw and the M5 nut? These will be used later in the final assembly. For now, since I got them out, I'm just going to kind of set them in here. Our M5 locking nut, the center here has the X pattern in it. So we'll take our locking nut and just get it aligned and pushed in there. Probably easier said than done. Easier done with small person fingers. Require a little bit of pressing. That would be where we'll grab our Nomar pliers that we got from KB3D Chris for Christmas. He got us a set of Nipix straight jaw Nomar pliers. They adjust out. We just need to kind of figure out where we need the adjustment set. And hopefully we can get this started. Okay, that went in there. At some point, I'm going to figure out a better place to keep those other than just in the box and on the floor. Need to get like a full set of drawers and stuff in here. Then we'll just take this and put it through here. And I'm not going to thread it too much. I'm just going to get the thread started. I don't even really want to get into the plastic. I just want to make sure that this is so. What's up next? Why did the ERCT MMU go to school? Because I wanted to learn about multifilamentary education. Now it looks like we're going to work on our selector. So we'll take this and put it aside. We're going to start working on our selector. A couple of M3x2 magnets. I think these are these really, really tiny ones. Looks of it. Got M3x2 magnets. M6x12x1 spring. I've got two different springs here. This one looks like the correct one, the one that's a thicker, bigger one. Grab the thicker one here. That out. Our LM8 UU bearings. For dryland bearing types. Do M2x10 self-tapping. We might have these with our servo. Some M3 heat set inserts, which I did dump in here. So we probably have already put the heat sets already in. M3x8, M3x12, and an M3x12. Eight. Oh, those rest of our printed parts, which we should have out here. We'll run into those as we need to grab. So we're going to start with this part, which is the main selector body. And we need to pop off some of the printed supports. So we've got a number 1 here. We need to pop this out. So we're going to use our screwdriver and work this out gently so that we don't mar or damage the print. Come on, you can do it. We can double check down here. We may have to go in and do a little bit of removal, either with a blade, make sure it's nice and flat, or with a file. Seems like it's pretty good. Okay, we've already taken off the 2 piece that was right over here, and we need to take off 3, which is this piece right here. So once again, we just wedge our piece in there, and the printed piece comes off, and that one looks good as well. Goes away. We're going to insert our bearings. Use a soft jaw vise or a flat object to insert the bearings in the hole. They should be flush with the print bed side of the selector kit. And these prints do have a little like ring rib in them that will line up with the ringed rib in your Dryland bearings. So good. Started. Grab our Nipix smooth jaw pliers again, but we're going to grab our big ones. Out how big we need them. And once again, these are smooth jaws, so we won't damage our parts. But we just still want to release slowly. Don't want anything to break. And we'll just keep adjusting these down. The nice thing is these are parallel jaws, so they're going to keep everything nice and in line as we are pushing these down. So we don't have to worry about standard set of pliers that would be working on one side and not the other. We're basically moving it straight down in parallel. Just one final squeeze. Ever so slightly, still proud of the printed part. Looks like. There we go. Do the same thing on the other side. We're just going to take our bearing, push it down in as far as it'll go to start with. Basically getting it past that first rib. Open our jaws up. Down. And the final squeeze should be able to get it nice and full flat. With both sides of the. Thanks once again to KB3D Chris for getting me these for Christmas. This is a surprise, and they have come in handy on every printer build since I got them. We got our bearings pushed in. Those are a very good, nice, tight fit. We've got all of our heat inserts in. We've already done that part already. We're going to take our drag chain piece here, and this is going to slide in this gap. Just like so. Sure it's pushed all the way in, and then we're going to do our M3x8 right there. The drag chain anchor into the dovetail groove on the selector part, install the M3x8 screw, and a drop of CA glue, and insert one of the M3x2 magnets right over on this side here. So we'll grab our CA glue, a Bob Smith Industries Sienna Acrylite gap filling medium. Going to put a drop in there. I have my magnets out. And I probably should have test fit the magnet before I did anything, but you know how it goes. Magnet is just push here. I just wanted to make sure that that got in there and was flat to the surface as possible, not at an that in there. We'll need our servo mount, which would be this piece. And this is for the MG90 servo. They highly recommend using the different type of servo, which is the Savox. But the kit that came with the Trident did come with the MG90 servo. That's the one we're going to be using. It came with the MG90 servo, and looking for servo and stuff. What did I do with the servo? Okay. So it came with an MG90 servo, which is why I printed the MG90 servo part out. Now I'm going to try and find the MG90 servo and what I did with it. And if not, I have a bunch of MG90 servos because I just bought a bunch for the Droid build project. Right in this corner. I'll be darned if I can see it here now. Running. Oh, there it is. There it is. So MG90 servo. We pop those two little pieces off. And it looks like there are a couple of more right here in the middle. So let's work to get those popped out. Further. You know, so that you don't break your part and have to reprint. This other side. And so I'm using the edge of this as a scraper to make sure and scrape any material off from the support material that may be stuck behind. If you use a knife or a blade, you may actually start cutting into the printed part, and then you'll have a different problem because you'll actually start carving material out. So try and use a flat surface, but not one that's truly fully a blade possible. So got those pieces out. Now on the MG90 servo, got it kind of like this, where the metal servo arm is side. Take our piece, and this round depression goes towards this side, and it's going to slip down right over the ears, will slip right in there like that to those parts that we just pulled out. Now we're going to use the screws that came with it to mount it in there. Now I'm just going to put the 3 horn pieces and the horn screw back in our bag. I'm going to set that in our box here because if I don't, I'm afraid that I will set it down and lose it again. Need our small Phillips head screwdriver. Screw these down. Hey, Pete, how's it going? Welcome on in. Hey, Hybrid Robotics, you're back. Unsettled. Uh-oh. Being these tiny self-tappers, especially the ones that use Phillips head, really do prefer the socket head cap screw ones or these Phillips head ones, but it is what it is, and we'll use what we got. This is on the selector arm. This is what we're doing right now is the selector. So give me 1 second. So we're working on this apparatus right now. So this is the servo arm. Not sure if it's the probe or not. Like I said, I've never built one of these, so this is just on the selector, and I believe this would be the piece that would push down on the, it would depress this down, I believe, so that it comes in contact with the filament and allows the drive gears. Hey, Hobby Main, welcome on in. So we've got those little fiddly screws in, but make sure that you've got them all the way in. Once again, the Phillips heads always feel like they're about to strip out before they're fully 100% seated. Got those in there. Just scroll down here a bit. Now we're going to install the spring cap. So we're going to twist the spring onto the selector spring cap. So that is this little printed piece here. Take this spring and twist it down on there. Just fits right on there. So there was two different springs. This looks to be the one that we will use. Insert the spring and cap into the hole in the selector and make sure it's not obstructed. Okay, now the hole in the selector is this one right here. And we did kind of make it a little wider at the top when we were setting that heat set down there. So I am going to see about just if I can get in there and cut some of the swarf off the top of that where I melted it. I'm really hoping that I don't wind up having to reprint this part. Don't think I will, but need to run a so in this. Not sure if you can tell, but you can see that little horseshoe down there. So when I set it, the edge of the heat set tool pushed an edge down. So I'm going to have to go in here with the reamer and try and open this hole back up and hopefully not mess it up in the process. Now, I need to scroll back up here. Talked about putting in the heat. Bore is 6.6. It uses 6 millimeter quarter or 1764 size bit. What I'm going to do is use a 6 millimeter reamer, so a reamer bit versus a drill bit, because a drill bit's going to cut into it, and I could literally like catch an edge and force myself down into the heat set insert, which would be bad. Where the reamer's not going to do that, and the reamer is going to get me a 6 millimeter hole. Oh, that done. By the way, I am angry with Disney Plus right now. I was trying to watch Bad Batch last night, and I was um I can get it to come up on my phone, I can get it to come up on my tablet, but I can't get Disney Plus. So see, that's exactly what we needed it to do. Once again, I'm going to pop that out. I'm going to grab the printed part, get that back at the bottom there, because that does go at the bottom of the spring. And it starts to screw this on, but I don't know about you, but it's not screwing onto my printed part, but that's that printed part does go into that hole. And the, whoop, ay, ay, ay. See this. Um, yeah, so I was trying to watch it, and I can watch it on my phone and I can watch it on my tablet, but I could not get it to come up on the TV. So that was very, very annoying. Have to try and work a little bit more. So the plastic part is just a little bit wider than the spring. So the plastic part's catching. Yeah, so I was mad at Disney Plus as to why well, I say Disney Plus, but it very well may be my Samsung TV did an update and now certain things won't load. But it lets me into my account. It just won't actually let me open my profile, which is weird. So I guess I'm gonna have to binge the first several episodes of Bad Batch on my um, laptop or first you don't succeed. Try again. So we now got the spring down in here with the printed part, you know, in there as well, properly mounted. So that's there. You get this out of the way. Okay, so next up, we're going to add the servo. And the servo has this angled part here. This becomes kind of a pivot point. So this portion is the part that goes in over the top of the spring. This is wider area, the shorter area. Going to go in there like that. Push the end into the depression in there. Then it will let it fold down. And then we're going to add a M3 by 20 screw through here. Interesting. Okay, like we're screwing it in through a heat set insert. So it's going to go through the heat set insert, and then this end is just going to be into a printed hole or depression, because all that we're doing here is this is becoming the pivot joint for this side, and the spring will be able to hold this up. So that's what we're doing here. Doo-doo. Yeah, so you'll notice here that there is bringing this here that is keeping that servo from fully seating down. That's what we're looking for. Tension screw installation. So here we're going to flip this over to the other side. We're going to run an M3 by 12 into this hole, and this once again goes through the plastic and through a heat set insert, and then goes into that cap underneath. That's going to set tension on the spring underneath. Only tighten and touch it until it touches the selector spring cap. Adjust the tension. Means basically go very light until you feel a little bit of resistance, or you feel that this starts to move. In fact, I will back this off, push this all the way down, just all the way down in there, and then screw in your screw until you start feeling resistant. You should feel resistant from that spring. You don't want to go any further because if you do, then you're starting to basically tension that. Don't need to do that. Just where's that up? Oh, what's up? Oh, we need to put a zip tie. So take our piece, put it like this. Yep, we got a zip tie hole right here, so we'll need some zip ties. They did provide some zip ties in the kit, so we'll use those for now. Just because I don't know how close they are to any of my others. Assuming that these are the right parts. Secure the servo wire with a zip tie. Make sure the wires lie flat against the side of the servo as shown. So we're going to make sure that it's going to lie flat. Going to try and lie it flat, but push it back so it's right in that gap a bit. Basically, I'm just trying to make sure that there's some strain relief there. You'll see there how I kind of pushed it. Whoops. I kind of pushed it down to where it almost goes right down by the edge and then comes over. That's just going to make sure that we have a decent amount of strain relief on that cable and get that cable as tight as possible. Then we'll cut that zip tie end off flush. Hey, Timor, how's it going? Welcome on in. We, we've done a little bit. We've got all of our laying parts installed. And now we're starting to work in our end and we're starting to work on our selector now. Now we're going to be working on the encoder. So we're going to need our V623 bearing. We did get a V bearing in this kit. I think I did pull it out and put it. So got a V623 bearing, or you could use a standard 623ZZ bearing. Need a BMG 3x20 stainless rod. Pretty sure we have one of those somewhere. There's that V groove. Probably a little bit better to use than the flat 623 bearing. Sorry, I'm thinking and looking and a BMG M3x20. Tyler gear without that screw. needle bearing. So basically a Bondtech gear set. There we go. Bondtech gear set. Another ECAS coupler. 2x8 self-tapping screws. We've got some of those. 3x8, 3x20, and 3 threaded inserts, which we've already installed. Yeah, we've just been working our way through our kit here. We are building the Enraged Rabbit Carrot Feeder version 2. We are building it stock, using a few parts from the V2 kit. A few parts is needed from the V1.1 kit that came with the Trident, and then the V2 parts where we need to from the Triangle Labs kit. So we've got this M3x8 and M3x20s. More. Inserts have already been installed. So this piece and piece is just one black coated encoder slotted wheel. Now, double check. Or and I had pulled out a binky sensor already because there was one in this kit. And I know it was here because it was in the foil, as most circuit boards are, like that type of foil. And what did I do with it? Didn't move anything off the table though. Well, we will find it, and hopefully we'll find it when we need it. We'll find it later if we need a second encoder, which I think we will need. Huh. This should be our binky encoder. Binky. Binky. So we've got that. We've got some wires. Oh, nice. We've got wires that have been pre-crimped. That's a pretty long wire. And we've got ends for both sides, but we also got another set of, in here, we got another set. We've got the ends for the crimps that are already on there. We got another set of crimps if we have to cut one edge off and tiny. Okay, the black encoder slotted wheel though. That is something I don't remember. Is that something that would have been in the kit, or is that a printed part, isn't it? Got a left side or right side. That would have been a printed part. Just going to check and make sure I didn't put it in the parts over here for cotton tape. No, they're not in here. I may have a missed part. Uh-oh. Why are you killing boards? Hmm. Not not seeing it here. I'm assuming that I was supposed to print that out, and a did I miss that? Did it not tell me to print? Give me 1 second, folks. Meanwhile, oh hey, first thing we're going to do is install that slotted encoder wheel, the one that I cannot find. Oh, yeah, that would be because it's a part that I did not print yet. Good news is it's going to be a small part, so did we print it in black? I think we probably should print it in black, huh? Yeah. Um, let me fire up a couple of only black filament that I have ready to go is polycarbonate carbon fiber, which would be black. Over in the K3, so let me that there. And get that started preheating. And that piece is located where? B2 STL. Good news is it's a 2-minute print. So let's see. Push this down. let's give myself a couple of options here. Meaning I'm going to print it multiple times since it's like literally a 2-minute print. And if I print them, I print one just too fast, it might actually cause a problem. But meanwhile, let's see if we can move ahead. And yeah, we're going to go ahead and print that out. We're going to print 4 of them. That way, if I bust one, I have the ability, I'll have spares. And if I don't bust one, I'll have spares to do the second one that I'll build in a little bit. I may not build on stream because I'll have to figure out which color I want to use. Start by fitting metal rod into encoder right. Next, slide on the needle bearings in the Bondtech idler gear and a small dab of grease or super lube on the bearings for lubrication. Slide the gear slotted wheel assembly into place. Slotted wheel should sit almost flush with the housing. Make sure it doesn't rub on the printed part. Okay. I was like, what tension spray is it talking about? And it's literally the printed part is printed with a spring mechanism. So it's whether or not this can spring down encoder. So we're really stuck until we get that encoder piece. The good news is I'm hearing things behind me get started, so that's the good news. Now what we can do while we're waiting is we'll fit our other magnet here. Now, and of course, we'll want this to line up and attract to the other one. I'm just going to get that one going there. Make sure that it will fit in the printed part. Not much ado. This is going to be a pretty tight darn fit. I'm going to open this up just ever so slightly, make sure it's a full M3 with my reamer. Get in there easily now. And it stays in there. It's not popping back out, so that's good. So door piece is good. Now we're just waiting for things to heat up so that we can get everything installed or get those pieces printed so we can get these installed, because I'm assuming once we build the selector, then we're going to start putting the selector together, of course. So while we wait for that to print, how's everybody doing? Hope everybody's doing good. Grandkids' hoverboard broke. Grandpa gets to teach electronics repair. Well, that's cool. Now with the board being stone cold dead, were you able to figure out like what the? I'm assuming if it's stone cold dead, then is it something on the power input side that you might be able to replace, or? Yeah, I hate when electronics fry. Right now on the Do Droid build, dang it, I still need to. So the Do Droid build, we'll talk about this for a little bit while we're chatting here. I kind of got them together and was working on the electronics, and you'll see that everything up here is kind of floppy. And the MG90S servos that we used on this for the head they're just too underpowered. It can't hold it together or hold it upright. So I need to swap all three of the servos in here for higher powered servos. So I need to order the right servos that I'll need for that, and then reprint all of the servo mounts because they'll be different. I think all the other parts are good. It's just the physical servo mounts that will need to be replaced with different servo or with different printed parts. And that includes the H that goes in this box that we had epoxied in. So really I'm going to have to take the whole arm apart. I'll cut the wires here, pull the servos out, and hopefully I can reuse these servos somewhere else later on. But everything down here is working, but the motors are reversed. So my option would be to literally come in here and I can roll the positive and negative on both sides, and the motors will turn in the right direction. But the problem with that is now I'm showing red going to negative and black going to positive. That's going to freak some people out. So I may wind up taking all the boards and everything out to get down, pull the motors out, desolder and resolder the wires the opposite direction, put everything back together. The other thing that I can't get to work is our DF player. I can't get I can't get any sound out of the speakers. So I did order a whole bunch more of these DF boards. So I'm going to pop this board out, put a different board in, and see if I can get that going. If not, I'll hit the Discord and try and figure out some troubleshooting there. But it's always good to have some spare parts, especially those small boards that are, 50 cents to $1 a piece. So Dio has been put on hold until I get new servos and some new get new servos, and I have to redo some of the wiring just so the motors are moving in the right direction, so it can do its self writing function. So we're kind of stuck on that one. We do need to start putting together the little battle bots that we were going to take to Rocky Mountain Rep Rap Fest with me. Might give my wife something to run around on the ground or up on the table for a little bit. But I have all the parts for those, and I'll look through, and those may be like a 1-day build type thing. So we may throw an extra stream in here and do like a 1-day build on that. Yeah, Nick, and that may be something that I do down in the future as well, because I believe I have a couple of spare ATX PSUs um, that I can use to build a desktop power supply, because I really like the idea of being able to do one of those. Um, but sorry, I'm like getting myself distracted here. Interesting. Um, could it have potentially just blown a fuse? I need to make sure that this is 20 millimeters while we're waiting. And it is. That's what I figured was another standard Bondtech drive gear. What we'll also do, that's the drive version, that's this piece. Yeah, I think once we get the encoder ring pressed onto this and we know that it's good, I will then go through and do my little shenanigans to grease up the needle bearings, because I really don't like the idea of, stick the encoder slot or stick the rod on, put the two bearings on, put a little dab of grease, right? Because that's what it's telling us to do, is slide the needle bearings and the Bondtech idler gear on, and then add a small dab of grease on the bearings for lubrication. Well, I'm going to make sure it's nice and lubricated like any of my other BMG drive gear bearings. We'll just press on the encoder piece first. Yeah, and I think you had sent the link over, so I've got the link to one or two of them on the Discord. I just need to grab, it's yet another project to throw, out here. And one of the projects I need to do is like take a new picture back here, because the one that's up on the Twitch site has a completely different printer lineup up here than what's up here now. We've got the DO build going. We've got the Trident 350 build, right? So we've got the Trident 350 build. We've got the ERCT build that we're doing for the Trident 350. We've got Cottontail over here. We've got Black Box over here. And by the way, Christian did send me some more of those M4 series 8, the 4040 T-nuts. Remember I had a bunch of them that were M5s. I went through and looked at the rest of them, and I had a total of 25 M5 4040 T-nuts. But yeah, like this right now is the project corner. So I got to be careful that I don't get too many more projects going. We've got the trad rack. So all the stuff for trad racks right up here. So I need to reprint and rebuild trad rack. And then I've got, well, and if they didn't change the lane design, I may not reprint the graphite pieces. I may just reprint the lime green pieces and then rebuild it, but we'll see. And then pretty much everything sitting up here on top of Fey Dragon is the parts for the two little death bots, or not death bots, but the battle bots. So yeah, I've got to start working on some projects and get some projects done. And now that Mrs. Dragon's gone, I'm going to take the salad fork and the micron downstairs, put them on the dining room table, and just start printing something. And probably I will print more of the maker coins, right? The Digital Dragon 72 coins. So I'll do these and just really to break those two printers in more, because I believe those are the two printers that I'm definitely taking to Rocky Mountain Rep Rat Fest. So yeah, KB3 and their nuts, sending me the wrong size nuts. Hey, at least he sent me oversized nuts, right? It would really suck if he sent me undersized nuts. And you know, so far I haven't dropped my balls everywhere. Though I will tell you what, when I was loading the lead weight, so I had 5 pounds of lead weight that I put at the bottom of Dio to help keep him stable. Gridfinity funnel. This opening was the perfect size to fit into one of the openings on each side, and I was able to distribute all of the ball bearings through here. And that's the same thing I'm going to try and do when I install the bearings in the counterweight, is use this funnel, because Chris was doing it up on his table and he spilt ball bearings everywhere. And he was talking about how, yeah, the funnel that I just dropped, where did it go? There it is. He said he's still finding those ball bearings. Yeah, yeah, he dropped them on his table, and they just kind of went everywhere. That is going to annoy me where the other sensor, because this kit did come with the Binky sensor, and the parts have finished printing. We're going to let it cool just a little bit. I'm going to look down here real fast and see if I knocked it off onto the ground. I'm not seeing it. Well, that sucks. Like I said, I know it's around here because I physically laid hands on it the other day. I just don't know where I actually put it. And I don't want to pull those parts. Um, yeah, like it's been sitting right here. Like it's literally, it's been sitting right here on the lid the whole time, and I keep looking right past it, saying, "Nope, no, it's not those." So yeah, this. Wonder if this is like an older version. So so this is Binky, right? Got the JST connector at the top. Got the spot to put a M2 screw into. Then the other side has a little bit of circuitry and our sensor. Right? This one that came in the kit looks to be a little bit different encoder. So it's got the three wire or the three pins that come up to the side, and its encoder looks to be going in a different direction. Right. So I don't know. This might be a different. Is this a different sensor or something? It doesn't say Binky. It does say FC123 out VCC and ground. Oh, you know what? Yeah, this is the one where the filament would actually go through the center, and this is the indicator light whether it's got filament in it. This is a different type of sensor for a different spot. It's a good thing we got the Binky because this is the encoder I'm pretty sure we want to use because this has the slot and our encoder wheel is going to go through that slot so it can measure how much filament is passing through it. Put that over there. And we're down to 85. We'll open the door smidge and let it. Build plate's kind of hot. Build plate was at 85. It should be hot, right? Here's our four parts. Build plate's a bit toasty. Single-sided honey badger build plate. And the K3, it just keeps going. It, like I said, it's printed all of the parts for black box out of our carbon fiber polycarbonate. So, which is what all these parts right here are. So, I haven't had a single issue with these, with that printer. Well, I'm looking forward to putting a trad rack on it and getting it going, printing some uh, multi-material or multicolored parts. What I'm going to do is try and look through here and find the best ones of these. Try that one first. But you got to be really careful with these and make sure that they printed very nicely. Once again, this is the sensor that's going to be saying, hey, your filament's moving through or not. That one's ready. So what we're going to do is we're going to bring this over here, and we've got our gear without the rub screw in it. Slide this down over the top. Oops, make sure we're going the right way. Goes this way with the how do we say this? Knurled piece with the knurling in it down, and flat piece up. Slide right on over. And what I'm going to do is I'm going to try and do a little twisting and make sure that it lines up with the print mat. It does. Then we'll take our slotted wheel push tool. And it says, use the slotted wheel push tool to gently push the encoder slotted wheel into place until it is flush with the end of the gear using a small hammer. We're going to use our thing called a thumb. And we're pretty close. We got down there a good ways already. And we kind of and that looked flat to me. So I'm going to once again do a once around these gears over this white paper towel to make sure that I don't have any burrs or flyaways or extra bits of filament in the way of these little teeth. Because these little teeth are what is going to trigger that encoder sensor. We want to make sure that they're nice and crisp and clean. Here to be. That's good. Now that we've got that done, we're going to grab our lubrication stuff. We're going to grab these other three pieces, put them aside so that we can use those for future. Grab our EP2 grease. We're going to take our piece, stick it down, or stick it on our finger. Put our two needle bearings in there. Put a little bit of EP2 grease in here. Bet you Liz just missed the fact that we busted out the lube on stream again. Take our steel rod, push it down in there, start feeling that pressure build on our finger underneath. Start to see one of the bearings rise out. We'll put it back in with our finger. Push this all the way through. And what that does is that will push all of that EP2 into the bearings. Then we'll just come back here with our towel and clean off the rest that leaked out the edge here. There we go. I got to do some checking too. We've got a couple of like 3D printing chat rooms at work that I just became aware of and joined. And somebody was saying like, hey, we've got some engineering teams that need a 3D printer that they can print like polycarbonate and like a print area of like 12 by 12 inches. I'm like, well, hell, that's like a 300 or 350, somewhere between a 300 and 350 bed. Like, if only I know somebody that builds printers that can print polycarbonate in that size. I don't know. I've got one, two, three, four of them sitting here right now. So, may do some chatting about that. Maybe make room for the 350 by taking one of my 300 2.4s over to him. Maybe I'll give him Chewy since he hasn't picked his up yet. Okay, so we've got this piece that we've already gone ahead and put our M3 heat set inserts into. And now we're going to need this piece. We're going to start doing our build out here. Now it talks about seating the this shaft right in this area here. So we're going to pick this thing up as its entirety as a unit. We're just going to push it in place. See if we can't get that to line up. See? Not. So I'm trying to get this pressed in. To the printed part. We've got our needle bearings and we've got our main bearing there. Now we need to make sure that our printed part is close to, but not like fouling out on the side here. Our encoder wheel needs to be close, but not flailing or rubbing. It is not. And then it says tension spring with first half assembled. Gently pull down and hold the tension spring. Release the brake. Prevents the encoder wheel from free spinning and filament is ejected. So this is there. It's going to prevent this from free spinning, supposedly, I guess. Feeling it drag. So now if I kind of push down on this should freewheel spin. Yes, it does. Like this, it drags, catches. But if I pull down on this bottom tension, that's working as intended. Now we need to install our Binky PCB. So the Binky PCB, and once again, our encoder tabs are going to go right through the middle of this sensor. This lines up. You'll notice as I slide this down in that slotted groove, the motor wheel right between those two slots. That's why that encoder wheel needs to be black, just so it picks up easy. We're going to take the screw that came with our Benke M2x10 self-tapping, line it up right there in the center, and that is a socket head variety. Use 1.5 wrench and tighten this down. You don't want to go too tight because you don't want to compress this and bust um, the board, but you also don't want the board to be wiggling. So kind of a good play on the tension. That's it right there. Everything is good. Now it looks like we're going to take these two halves and mate them together. So the rod is going to come through here, and there is a small depression. Rod's going to go, and everything should up to include the board halves where everything's. And so what I'm finding is this shaft is still protruding out too much. Let's see if I can push that down in there a little bit more. So that we were oh, careful. You don't want to jam in and bust your sensor. When everything lines up, it will pop in. Going to kind of be able to look down there, double check that our filament path is lining up. That's good. Now we're going to come in from this side with the two of the M3x20s. This one and this one. This back here is an M3x8 button head. I need to find the button heads, and if there aren't any in here, I will use my own. An M3x20 is not, is an M3x16. Well, would probably be why it's not going and reaching the screw on the other end. Victory. So how's everybody else doing today? Hopefully your days are going well. Days, your evenings. And an M3 by 8 button head. Yep, right here. Also see there's some more controversy going around in the 3D printing communities again. This time dealing with Anycubic and their implementation of Klipper. If somebody found a exploit screw and tap the M3 socket head into the plastic hole in the tension spring. They stand off for the homing in-stop micro stated in the. Okay, well that makes sense. I don't know if it's supposed to go all the way in or not, but I'm going to make it go all the way in very lightly. Stop right as I touch so I don't um, strip the plastic in case I do need to back this out some. Now I will need another M3 by 20 and the V bearing. V bearing. This is going to sit right inside this slot here. Put that in, line it up, and screw it in. Now I'm going to screw this in until it just touches it. And make sure that that bearing still runs cleanly and easily. Use your set. Okay. Now we need to get an ECAS fitting in here. And it did say that don't screw these all the way in so we get the ECAS fitting in there. So we don't have any issues trying to get the ECAS. Boom, that part's in. Go ahead and just snug these up. Everything's good there. We'll need to get the blue piece of the lined up and press that in. Darn it. Okay. And it does say the small length of filament to make sure that everything is running smoothly. Doesn't run on the encoder body or binky PCB optical. Okay. And which way are we moving said filament through here? Coming through the front ECAS fitting. Going through our ECAS. Sure if you can see that the spring popped out some. Bearing is turning. So everything here is working. And I'm not sure if you can tell, but our spring does open up just a little bit. Filament goes in. So we're good. All righty. What's next? We're going to now install our encoder to our selector. We've got a setup like this. Okay, we're going to remove the N3x20 that we inserted for. Secure the encoder to the selector cart with the two N3x20. Okay. Because this one's holding the other end of the servos. We need to pull this out, keep our servo end in place. Slot right in there. So, and we'll put this M3x20 back in. I want to double and triple check that was a 20 and not a 16. That was a 16 anyhow, so we need to grab two M3x20s. It was good that we temporarily put that in there and that it was a 16. So. Okay. That side. Over here. Okay. Here's our setup now. Now we'll need to install the door and our door piece here. We'll line up over here. And we're going to use a piece of filament through this door to hold it in place. So, Pop Pink is still on Fade Dragon. Where's the Pop Blue? Blue, Pop Blue, Pop Blue. Pop, 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 pop. Oh, oh. Pop Blue ASA. Not enough to break a piece off for it. Probably going to be a very tight fit. Is let me see drills. I've got a something other than a 0.2. Got a 1.5, which is of course a little smaller than what I need, but that should enable me to get in here, clean this out, and possibly open it up if need be. Lined up, make sure that we're lined up. Fuck this up. I don't want to use the 2mm because that would be too big. We use this 5mm or the 1.5mm. We'll just kind of, run around the edges, try and open the hole up a little bit. Hopefully that helps. Well, I mean, we're almost there. Nothing says we've got to be pushed all the way through. So we'll just go ahead and snip this off on this side. And use this to push this a little bit. Force it with a hammer. Well, yeah, I could. Just don't want to. Like I said, it's in there far enough. It's like literally within a millimeter of coming all the way to this side. That's plenty enough The hinge is set. I think we're good. Now we need to install the tensioner, belt tensioner, into the side. That would be this piece here. And this is going to go in with an M3 by 20 as well. And I'm going to figure out why that feels like it's right there. We're just going to set that in there. Put this M3 by 16 away so I don't keep trying to grab it thinking it's 3 by 20. You need more hammer in the stream, but we don't use hammers. We use right, like that's my hammer, right? It's got a little bit of rubber on it, so it's a dead blow. This is just going to go in and go into the heat set on the other side. Be our belt tensioner. And now we're going to start working on the linear axis. This part right here, we're going to take and put it aside with the rest of our build so far. And we're nice and good there. Linear axis. Floated view. 8mm rods. Yep, got 2 of those. 8mm rods. And we're going to put that right there for the time being. A couple of screws here that I don't need. Got rid of that other little tiny magnet. ET2 22 pulley. That inserts we would have already used. You know, with the way I struggle with these little bags these days, good thing I am not a drug addict. I would die of trying to get a fix if I needed to open these. Need 6 and 3 by 8. Or 6. 2 and 3 by 12s. Try and keep using black hardware, so I'll grab some out of my own. 2 and 3 by 12. M5 by 30 button head cap screw. 5 by M5 lock nut. And the M7 or the N17 pancake book. Yep, we got that over there. More Ugga Duggas, yep. Actually, no 5-pound. I've got I think it's a 3-pound. It works really good. I've got the dead blow, the 3-pound. Yeah, no 5-pounder. 5-pounders would do a good deal of damage. I think we've got everything that we could need. That inserts we've done. So start with is taking our cable chain piece and we mount it right right here on these two, like this, with our M3 by 8. Yeah, why that 3 by 8 going in. This is the other one. Okay. Okay. Um, we use M3 by 8s to mount the motor, and the wire on our motor comes directly out from this slot. We're going to come in this way, mount the motor, make sure that your things line up in that slot. So you've got to put it in there. And you've got these parts right here have a little rise to them. So you will add your motor lock. It'll sit right down on there, slide between the motor and that piece. That's going to lock your motor in place. We're going to put in our 4 and 3 nuts. Okay, here we go. Now we're going to need the other piece here. For this piece, we're going to need the GT20 idler. Okay, told me to put the pulley on you. We're going to do the idler. So idler goes in, 5 by 30, goes through idler, and we're going to need our M5 nut down here. 30. A good catch. I'm like, would I be running out for that many days. That and this, we'll take this. Oh, and get it pushed down in there. Pull in. For M3 driver. And it doesn't really tell us like crank on it or not. I'm going to say crank on it a little bit until you feel that your screw is fully tightened, but that your bearing still rotates freely. You want to make sure that you're into that, whoops, the nylon locking material, not, then the screws or the bolt's really not doing its job. Okay, now, fun side, or the fun, using LM8 UU bearings, lightly grease them with EP super loop. Dryland, which is what we have, do not need to be lubricated. Idler side, this side. Carefully insert the 8mm smooth rods through the LM8 UU bearings, electric heart, and fully into the linear axis block. Fully bottom out. There are holes to let you know that you've gotten them. Or I put that selector on. I'm going to try and run these in here and see how hard they are to get in and get fully seated. So I'm seeing it there, but it's still not fully seated. We're going to have to do some, watch your ears, folks. Some slight percussive persuasion. Make sure that it's fully seated. Okay. Now we'll do the other side. Same thing. Hold your ears, folks. And you should be able to see the reflection as the sides are all the way in. Now, I'm going to make sure that I've got the right orientation so the idler facing up. My selector, I've got the idler on the left side. The encoder is facing me, and my chain mount is facing away from me. This is how this is supposed to slide in. Now we just need to line up our bearing blocks. Flip our bearings in, push it all the way down. Okay. Now on the motor side, don't fully insert the rods on the motor side. Set them in a central position and just get the two M3x12 socket head screws to contact. Add the pulley and snug the grubs through. We will adjust soon. So I'm probably going to go ahead and put the pulley on here now before I attach things. GT2 pulley, we're going to need our Loctite. You like the color choices? Thank you. So this is the Polymaker ASA Pop Pink and Pop Blue. And I went with that for the Enraged Rabbit Carrot Feeder because it matches the color scheme of the Trident 350. So the Trident 350 kit came with a Enraged Rabbit Carrot Feeder version 1.1 kit, and we bought a Triangle Labs V2 upgrade kit, and that's what we're building is a 8-part V2. I'm just getting my grub screws ready. This goes on in this orientation. So like I said, we're just going to line it up. Just going to get it flush with the top of the shaft and snug up the flat. Not going to worry about snugging up both just yet. I just want it up against the flat so it's on there and out of the way. Now these two, what I want to do, I'm going to take my M3 by 12 screws and insert them partially. Once again, these are coming in through heat set inserts. We're just going to insert these partially, try and make them about the same length. So that when we put our rods in, we're going to bring our rods right up to the screws. So we need to make sure our pulley's on, our pulley's on the top over here. So we need to make sure there are motors on the top over here. That's how these in. And we're going to line up our rods and just push them together. Watch our cable. And we should feel them go in until we've hit the screws on either side. And we're good. Okay, so that's our top build so far. Pulley and belt installation. We need to install our belt and run the belt clockwise from the selector cart around the idler and back to the selector motor. Back to the selector. You guys back a little bit. Easy up so you can get a little bit better, wider view of what I've got going on here. Table. This is what we've got. Our selector. We'll kind of move that over here in the middle. And our belting is going to start here, go around this pulley, and then back to the belt. So we had belt that it came with, and then other belt that they gave us. I think the belt that it came with is probably still going to be long enough. And the love and joy is trying to line these up and getting them push down into the grooves of the belt clamp area. Nicest one that I've ever had the pleasure of trying to put in. I'm using my fingernail because my fingernail has been, fingernails are cut fairly short. If you're worried that you may bend over a fingernail, just use the flat edge of a screwdriver to make sure that you get this pushed down into the slot all the way. Okay, there we're going to come around our idler, and we can come out the back and then push it back through like so. Almost made a boo-boo. I didn't check to see if my letters were on the up and up. Come around our pulley, and then we would come back in and we would lock it down on this side. Now what does it say as far as our back to the selector card? Mark the belt length with a paint pen or marker. Now measure an additional 10 millimeters of length. Cut the belt to the new mark. This ensures room for adjustment. And okay, so we're going to make it extra long. So I'm going to line it up with the end here. Does line good. And I'm just going to say, like right here to the end, that is about 10 millimeters or so. I'll give it like one extra. That's where I want to cut my belt. Okay. So there's the cut. And unfortunately, if I need to, I've got belt here and I've got plenty of other genuine Gates belt if I need to, if this winds up being cut too short and I just had my head up my butt. How's it going, Urban Monkey? You're waiting on micro switches to build yours? Yeah. And you got your MBB today? Nice. Like I said, I've got two MBBs and four of the drivers, so I've got enough to do two of these. So I will be putting a second one together. I will match the color scheme to one of the other Vorons. I just need to figure out which one I'm going to put it on. I may actually make it match the fluorescent red and old copper of the Trident 300 and go that route. And of course, it gives you the approximate length here, but we're good. Work buttons. Okay, so do I just leave the belt loose or do I actually, like, I guess I'll put the belt in here. Very least, I'll put it in there. Need to pull it out, I will pull it out, but it's on there. I'm assuming the length adjustment is going to happen when we put it on the part. And we're towards the final assembly. Wow, we're trucking right along here. Point of view, we've got our drag chain. M3x8 flathead cap screws. Do I have those? They kept in here, but I'm sure that I will have plenty somewhere. I know. Well, I know I have plenty. Got our drag chain. I had some extra links with 2 ends. Asked me why they broke down the drag chain just to put it in there. So be it. Here's all of our drag. Yeah, I don't have those flathead cap screws, but I will grab some because I know I have some inner locking nuts and 5x30 socket screws. We're going to start on our selector piece here on the motor side. Need to put in another nylon lock screw there. That ready and got and installed. All right. Grab this. Damn it. I just cracked that part. Oh, I cracked that one to all get out. Crack here, crack there, crack up underneath the motor. Ooh, yep, and there it went the rest of the way. So I just threw it across the room. So we're gonna have to reprint a part or another part, which means tonight, good time to call the stream. Because like I said, I'm gonna have to find the M5 nut that I just threw halfway across the room. And then 2, I'm gonna have to reprint this motor mount, take some things off, and rebuild the motor mount side here. Yeah. So with that said, let's see who we have that we can wait out to today since I just broke apart. Now the good thing is I've got this color already in the printer, so it's just a matter of firing it up and bringing it back out. I've got plenty of it in there for that piece, so I'll get that sliced and ready to go here. If you guys could, let me know if there's somebody in particular you would like to raid out to. And like I said, I'm going to have to reprint that part. Peace. Um, do the parts fly only in pieces? Yeah, exactly. Jeno streaming? Okay, great. Yeah, so I just got this part sliced, and when I sliced it, I went ahead and just sliced it for 100.2, so just zero point 0.2 oversized. And I don't think that's going to change things too dramatically, but it might give me an easier time of putting that next bolt in without breaking anything. Um, yeah, so I'll go ahead and all of the M3, I'll get everything cut over basically off stream so that when we come back to stream, we'll be ready to start off right where we are. And I'll press that nut in, and if I break it again, then I'll reprint it again. And then I'll try a different M5 nut, like one of my other M5 nuts. Could just be a out of spec M5 uh, nut. So yeah, we'll do that. And then maybe we get an extra stream in. I've got no adult supervision, so there's always a possibility of throwing some extra streams here and there. So maybe we do an extra stream tomorrow night and finish getting the ERCFA together, and then we can do, I don't know, we can start working on Cottontail. All right. So let me, while things are heating up, the other thing I need to print is I still need to print the translucent pieces for the LEDs. So I'll get those printed as well. But while that's starting up, let's go ahead and get the raid out started for Big Jano. All right. So thank you everybody for being here. I will see you next time. Like I said, there may be an extra stream thrown in tomorrow. We never know. Keep an eye out for that. If not, Saturday for sure is Black Box Section 2, which is the Z-axis. So we'll be working on Black Box on Saturday, regardless if I see you between now and then. So everybody, have a great night. Thanks for being here. Raid with me over to Jano, and I will see you guys here in a day or so. Bye now.